I'm Becca.
Mi nombre es Pablo.
My name's Sam.
Thanks for watching us on DPS TV. Hi, we're going to take a moment to learn a little bit about simplifying radicals today. So if you take a look at my screen, I'll explain what a radical is, and then we'll explain how to simplify it. So a radical, anytime you see that little check mark sign, you kind of see that over there, that little check mark sign, that is a radical sign. The most common one and the first one you usually learn about is the square root. A square root is the opposite of a square. So when I'm finding the square root of something, I'm trying to find out what times itself, twice, equals that. So for example, on the right here, I have the square root of 25. The answer to the square root of 25 is 5 because 5 squared equals 25. We also could say that the square root of 25 has two answers. We could say -5 as well, because -5 squared, or -5 times -5, equals 25. So we're going to say positive or -5. A cube root, so you can kind of see over on the left here, a cube root, now we've got that radical sign there, that check mark sign. It's a radical sign with a little baby 3 there. A cube root, that's the opposite of a cube. So what we're asking ourselves when we're solving these or simplifying these is what times itself 3 times equals that number? Or in other words, what cubed equals that number? So for example, if I'm looking at the cube root of 8, I'm trying to think about what times itself 3 times equals 8, or what cubed equals 8. And that number is going to be 2, because 2 times 2 is 4, times 2 again would give you 8. So 3 2s, or 2 cubed, gives us 8. The last one we'll talk about, and you could really go on forever with these, is fourth root. And as you might have guessed, it means what times itself 4 times is equal to what's underneath the radical sign. So again, for example, over here, 81, what times itself 4 times would give you 81? And the answer here is going to be positive or -3, kind of like our square root, because I could take positive 3 times 3 times 3 times 3 and get 81. Or I could also do -3 times -3 times -3 times -3 equals 81. Or the other way to think about that is -3 to the 4th power. So what we need to know is that square roots are opposites of squares. Cube roots are opposite of cubes. Fourth roots are opposite of the 4th power, and so on. And if you know what opposites do, is opposites cancel each other out. For example, if I were to add 2 to something and then subtract 2, it's like we didn't even have anything to begin with. So they cancel each other out. So let's say I did something squared and then square rooted it. It actually just cancels each other out. So if I squared x and square rooted it, I'm back to x. So that's an important concept to know when we're thinking about how we simplify square roots. Sometimes, or simplify radicals, sometimes, like on the right there, we get a nice even number. Sometimes we don't, and we may get a decimal, which is definitely something that you could write your answer as, and your calculator can handle that. It's usually a calculator thing that you do. But sometimes it's not a perfect square, and we want an exact answer. We don't want a decimal approximation. So what we can do to do that is to simplify it. It doesn't get rid of the radical, but it makes it a lot simpler. So my first tip when doing this is to factor the number or term that's underneath your radical completely. So for example, if I had 40, I would break that down to all of its prime factors. So I'd say maybe 2 times 20. 2 is a prime factor, back to that factor tree that you maybe learned in elementary school. 20 we could break down more as 4 times 5. 5 is a prime factor. And then 4 we can break down to 2 times 2. So the prime factorization of 40 is going to be 2 times 2 times 2 times 5. So what we need to know, or the reason why we do this, is the square root of 40 is the same as the square root of 2 times 2 times 2 times 5. Now, since we're doing square root, and a square root is the opposite of squares, what we're looking for is pairs of 2. So you can see that these two factors are the same. You could also maybe even think about this as 2 squared times 2 times 5. That being said, 2 squared, we looked at above how a square root and a square cancel each other out. They cancel each other. So what we're just left with is this 2 right here. We're just left with that 2. The square goes away because the square root gets rid of that 2. So that goes on the outside of our square root. On the inside, these two numbers, 2 and 5, those are not being squared at all. So that square root can't cancel any of those out at all. So we just have 2 times 5 on the inside. Or a simpler way to write it is 10. So this radical, simplifying it, would look like that, 2 square roots of 10 instead of the square root of 40. It's a more precise way, it's an accurate way to write a completely accurate answer without estimating. So a similar concept works for cube roots and fourth roots. So I'm going to start, same deal like I did over here, where I am going to find the prime factorization of 24. I'm going to do this kind of quickly because this video is not on factoring, it is on simplifying radicals, and I'm assuming you know factoring by now. So what we would say then is that the cube root of 24 is the same as 3 times 2 times 2 times 2. Now what I'm looking for here, since it's a cube root, is pairs of, or groups of 3. So you can see this 2 times 2 times 2 times 2, it's a group of 3. So I could rewrite that as 3 times 2 to the third power. As we mentioned before, cube root is the opposite of a cube, so that cancels out. So this would cancel with this. So this 2 is going to come to the outside of our cube root, because we did the cube root of 2, and that 3 is left on the inside. So this is now the simplified radical form of cube root of 24. This can also work with variables. So if you look at the last example I have on the right here, we're going to still do the prime factorization of 32. Let me maybe do this in a different color. Prime factorization of 32, so factor tree again. So we have 16 and 2, 8 and 2, 4 and 2, and then 2 and 2. So rewriting this fourth root, I have 2 times 2 times 2 times 2, there are 5 of them, times x to the 6th, which I'm going to break this down as x to the 4th times x to the 2. The reason why I'm doing that is because I'm trying to find groups of 4. And I know if I have 6, I have one group of 4 and I have 2 left over. And then I have y to the 4th times z. Let me move this over so we can see. Okay, so back to what I said about groups of 4, we're going to take that 2 times 2 times 2 times 2, the 4 of those 2's, and I'm going to write that as 2 to the 4th power, just because, again, we know that we're looking for groups of 4, and our powers and our radicals cancel each other out. So what you can see here, and I'm going to highlight these so you can see it. Yeah, where's my highlighter? Okay, here it is. So I've got a 2 that can come to the outside. I have an x that can come to the outside, and I also have a y that can come to the outside, because those are all powers of 4. So we're going to put a 2, an x, and a y on the outside, and then once we get rid of those, you can see what we have left on the inside is a 2, x squared, and a z. So you can use this idea of simplifying radicals with variables as well as numbers. But a big tip in doing this is to just find the prime factorization of it, because that really helps to see what you can pull out and what you will have to leave in the radical. So hopefully this helps with simplifying radicals. This will definitely apply to a lot of different things that you do in math, so hopefully that helps.